Hi there. In today's lesson, I want to look at polynomials and factoring out polynomials. So the purpose of this handout was for you just to think about what it means to factor out a polynomial and kind of go through that process yourself. I just start off by saying something about the heart of algebra being a relationship between numbers and variables. So that's what algebra is. It's not necessarily just equations with variables in it. It's actually looking at a relationship between numbers and variables. And with that, polynomials is involved. We'll be talking more about algebra as we go on through the year. So definitions of polynomial, binomial, and trinomials, they're all in your textbook at the back, and I think everybody should copy that out. An example of polynomial would be maybe x plus y minus z equals 5. Actually, you don't need to have a minus. Plus 5 maybe. A binomial is a polynomial with two terms, so it could be x squared minus 2. That's a binomial. So bi meaning 2. Trinomial, tri is 3, so that could be maybe x squared plus y plus 15. That would be a trinomial. 3 different terms. I next ask you to evaluate this expression. So this incorporates the distributive property, where we take the first term and multiply it by every other term. So that's equal to 5 times a plus 5 times 7. So I'm using a dot here to represent multiplication. Now that we're using algebra and we're using variables, x is a very common variable, and we don't want to confuse x with multiplication, so we use this dot instead. So that's also equal to 5a plus 35. I then ask you to look at this expression. It's a little bit harder. I think most of you have seen this before. If not, you'll see more of it. But essentially you multiply each term in the first binomial by each term in the second. So this would be x squared minus 2x and then plus 3x minus 6. And that can be simplified a bit because these two guys can add up together. So that's x squared plus x minus 6. Alright. The next part on the sheet was just to get you thinking about what it means to factor something. So one method of factoring is to use a factor tree. To give an example, you could start with maybe 18. That factors out to 3 times 6, which factors out to 3 times 2. So it's 3 times 3 times 2, or 3 squared times 2. And that leads into the next step. So this is where things are getting kind of new. We're going to do the same kind of factoring with this guy, 8d. So I think most people say, well, 8d, how could I factor something out? Well, I could multiply 2. If I wanted to factor out, say, 2 times what gives me 8d? Well, that would be 4d. And then a lot of people say, well, that can maybe be factored again. That's 2 times 2d. And I think a lot of students starting off with this will leave that. They'll say that's the answer. 2, 2, and 2d. One thing I want to be really clear on is the d and the whole number do not always have to be connected. D does not need to hitchhike along with 2. It can actually be factored as well. That's 2 times d. So the factors for 8d are 2, 2, 2, and d. We do the same thing for 12d squared. That could be a 2 times 6d squared. 6d squared could be 2 times 3d squared, which could be 3 times d squared, and that's a d times a d. So the factors for 12d squared would be 2, 2, 3, d, and d. Or maybe we could say 2 squared times 3 times d squared. It's the same thing, but these are the prime factors of 12d squared. So the next step, or next thing you're asked, is what's the greatest common factor of 8d and 12d squared? Well, we've factored out everything here, so we should be able to get the answer to that question just by looking at our factors. There's a 2 here and a 2 there, so 2 is one common factor. So there's another 2 there, another 2, so there's another common factor. There's a 2 here, but no more 2's. But D, there's a D in each one. So those are the common, that's the common factors. So the greatest common factor would be 2 times D, 4D. The last thing you're asked to do is to factor out the greatest common factor from that binomial. So here's the binomial, and we want to factor out the GCF. So that means we're going to start with 4D times something is going to give us 8D plus 12D squared. Okay, that's going to equal 8D plus 12D squared. So the question you can ask yourself is 4D times what is going to give you 8D? That would be 2. And then 4D times what gives you 12D squared? That would be 3D. So there, this is the answer to, or the solution to what I was asking. 4D times 2 plus 3D is the same as 8D plus 12D squared. And we can expand this again just to double check. So 4D times 2 is 8D. 4D times 3D is 12D squared. Yeah, works out. So now on the next side of the page we have a couple examples to work through. I'm gonna go through them, like showing all the factor trees and that. Once you get used to this stuff, actually some of these polynomials or trinomials are very easy to factor out just by looking at them. But we'll work it all out first, or I will at least. Okay, so 6 is a 2 times a 3. I'm not going to worry about the negative signs just yet. I'm just going to concentrate on the factors. So 12z is 2 times 6z, which is 2 times 3z, which is 3 times z. And then 18z squared is 2 times 9z squared, 3 times 3z squared, 3 times z times z. Okay, so we got all the terms factored. Let's find the greatest common factor. There's a 2 there, a 2 there, and a 2 there. There's a 3, and a 3, and that's it. There's no more factors in the 6, so we know that's done. So GCF is 6. So we want to factor out the greatest this is supposed to say factor, by the way, sorry. We want to factor out the greatest common factor. So it's going to be 6 times something. So 6 times what gives you 6? Well, that's a 1. 6 times what gives you negative 12z? That would be negative 2z. 6 times what gives you negative 18z squared? That's a minus 3z squared. So that's the answer to the question. Just a little note about conventions. Usually we order the factors, or the terms in a polynomial, with the highest order term first. So the highest order meaning the variable with the biggest exponent. So this is usually written like this. And then the next order, then this. And even more, we usually make sure that this first term, this guy, is positive. So if I take a negative 1 out of each of these terms, I can make this a negative 6. A lot of words, easier to see, I think, if I just write it. So if I make that a negative 6, that makes this a 3z squared plus 2z minus 6. So I would say that's the best way to write the answer. We can then double check by expanding. So negative 18z squared, negative 12z, and ooh, that's supposed to be a 1. Good thing I did in this check. Negative 6 times negative 1 is positive 6. Yep, that's what we started with. Okay, so that worked out. The next one we'll do the same way. 20 C4 D, 2 times 10 C4D. That's 2 times 5 C4d. That goes into 5c to the fourth and a d. 30c cubed d squared. 2 times 15 c cubed d squared. 3 times 5 oops, c cubed d squared. And the last one was 25 cd. It's 5 cd. Okay, what's the greatest common factor? This has a 2, this has a 2, this one does not have a 2. This has a 5, has a 5 and a 5, so 5 is a common factor. This one has a 5, no more 5s in this one though. This one has a C, that one has a C, and this, so C is a common factor, and that's a D, that has a D, this has, so D is another common factor. So the GCF is 5CD. Alright, now we'll do the factor that GCF out of the polynomial. So we have 5CD times something. So 5CD times something gives you negative 20c to the fourth. That'd be negative 4c cubed. 5CD times something gives you negative 30c cubed d squared. That would be negative 6c squared d. And 5 times something gives you negative 25cd. That would be negative 5. Once again, I would move the negative part of this term into the factor on the outside. So I'd make this negative 5cd. So that's going to be 4c cubed plus 6c squared d plus 5. And we can double check. So this is negative 20 c to the fourth d minus 30c cubed d squared minus 25cd. Check. That works out okay. One last thing is I realized after doing this lesson that some people may not be familiar with the idea of like c times c cubed is equal to c to the fourth. And we're going to go over that later in the year when we cover exponents. For now I can just show you the basic rule is like if you have an exponent, let's say c2 times c to the fourth, that you can add those exponents. You can double check this with your calculator. You can try like maybe punching in 3 squared times 3 to the fourth. See what it is in your calculator, then try doing the same thing with 3 to the sixth. And you should see it's the same thing. Okay, that's it for today's lesson. If you have any questions, come see me. Thanks.